Hi, this is Margo. This is Saturday afternoon, November 2nd, 2019, and today's show is going to be about the methane plume that these Russian scientists have discovered off the Bennett Island in off the coast of Siberia, in the East Siberia Sea, or the Siberia Sea, East Siberia ice shelf. This has been in the news for about a month now, and I've not reported on it, but I've got some things to bring to the table on this as well, just so people can become aware of it. There are two articles that we're going to look at, and then we're going to look at some other things too. The first one is from the Telegraph, and other people have reported on this, but I've not done it yet. So here we go. Russian scientists find most powerful ever methane seep in Arctic Ocean. There's the picture of the ship that went out. And this article is from October the 8th of this year. Russian scientists in the Arctic Ocean said they have discovered the most powerful methane gas fountain ever recorded, highlighting the danger of this greenhouse gas accelerating climate change or causing an oil or gas spill as it erupts from thawing permafrost. A research expedition from the Tomsk Polytechnic University found the seep, as methane leaks are known, east of Bennett Island in the East Siberian Sea, where its violent bubbles seem to make the water boil over an area of 50 square feet. The concentration of methane in the air there was up to 16 parts per million, more than 9 times higher than the atmospheric average. I'm going to stop right there. First of all, normally we're used to talking about parts per billion, so people don't know what that relates to, 16 parts per million. I did a simple search and found a converter, and if we so what was that? 16. Okay, I accidentally typed in 18. 16 parts per million is equivalent to 16,000 parts per billion. So that's more than the chart on CAMS. And this is at surface level that they measured this. So I have CAMS pulled up, Copernicus Atmosphere Monitoring Services. If you're familiar with my work, you know that I look at this a lot, and I like this because we can see the methane in different colors here. And this is the latest data from Thursday the 31st. This is the Arctic view, and this is surface level. And so the chart down here, in the highest area, it only goes up to 10,000 parts per billion. So we're talking about 6,000 parts per billion higher than the highest reading on CAMS. And so this dark brown, the darkest color here, is between 2160 and 10,000 parts per billion. Now remember, they changed this color ledger in December of last year, 2018, and it used to go up to 75,600, but they downscaled all the colors, or upscaled them, or whatever you want to call it, to reflect different colors but higher readings. And so I've been documenting the CAMS data every day and posting it for my members on my Subscribe Star page. And the Bennett Island is about here. We'll look at that in a minute too. Let's do a zoom in. if we print this, it goes to a PDF file that can be downloaded, or we can zoom in and I can show you exactly where the Bennett Island is. It's right here. It's very small compared to everything else here. So here's Siberia. This is the East Siberia ice shelf. This is the Siberia Sea. This is the Laptev Sea. Over here is the Kara Sea. This is Novaya Zemlya. And we've got Greenland. Here's the North Pole down here. Alaska, Canada, and so on. So this expedition went out the first part of October, and in my documenting, I did not see anything in that range in this part of the Arctic. And I don't know if it's not a big enough plume for it to register on their meters here, if it has to be a wider area or what. But it's not showing up on cams is what I'm saying. But this is, and it would show up in this dark brown color like you're seeing over China and different parts of Siberia and over here in the United States and different things. So there's that. So I wanted to show you that. Now let's go back to the article. So 16,000 parts per billion, and the world average is about 1,800 parts per billion of methane. So it's a huge amount. 16 parts per million, which says more than 9 times higher than the atmospheric average. Well, they're calling the atmospheric average around 1777. It's about 1,800. It goes on, this is the most powerful seep I've ever been able to observe, lead scientist Igor Semilitov, who has participated in 45 Arctic expeditions, said in a statement this week. No one has ever recorded anything similar. Now, he is the partner of Natalia Shikarovich, who they did these expeditions several years ago and drilled into the sediment of the East Siberian ice shelf and found the methane bubbles and the hydrates, and she was the one, Natalia was the one that's where we get the term the 50 gigaton methane bomb could go off just any time. That came from her work. So they worked together on this stuff. So Mr. Semilitov warned last month that the sudden release of gases from underwater permafrost could harm oil and gas infrastructure. So of course this is the take that they're taking on this, that it's going to harm, all the stuff that they've got built up there, with the offshore drilling and all that. He goes on, if we don't take into account research results about the condition of underwater permafrost, geological catastrophes similar to the Deepwater Horizon accident in the Gulf of Mexico could occur during exploratory and commercial activities, which could cause irreparable damage, he said. Although Russia has only one offshore oil drilling rig, it has been rapidly expanding the transport of liquefied natural gas in the Arctic. The threat extends to the nuclear power units, including seafloor reactors, that Russia has been considering for Arctic development. That's not a real smart idea, I don't think. In August, state concern Rosatom launched a floating nuclear power plant to power the gold mining outpost of Pevek. When researchers drew near to the emerald-colored water of the methane fountain, they could see how gas was rising to the surface from the black depths of the sea in thousands of bubbly strands. They took samples of bottom sediments, water and gas, scooping up the extraordinarily large methane bubbles in buckets rather than small plastic capsules, and filling several pressurized canisters. The next day, the expedition stumbled upon another giant seep of roughly the same size, even though discovering seeps among rough ocean waves is usually harder than finding a needle in a haystack. The group set out last month on a research vessel to study the scale and effects of methane gas emissions from underwater permafrost along the northern sea route, which Russia hopes can draw shipping away from the Suez Canal as the ice melts. The project also includes scientists from the UK, the United States, Italy, the Netherlands, and Sweden. So I'm going to stop there for a second. As this sea ice thaws, they're opening up shipping routes to go all the way through the Arctic, and so that's what they want. They want the ice to melt so they can send ships up through the Arctic and around, instead of having to come down this way, down to the Mediterranean through the Suez Canal and down around. So that's the plan, and I've covered that as well. This permanently frozen soil lies under 2/3 of Russian territory as well as much of the Arctic Ocean. It's been thawing as the Arctic warms at least twice as fast as the rest of the planet, cracking buildings and pipelines, hampering agriculture, awakening ancient diseases, and releasing more greenhouse gases. Methane is especially dangerous as it can warm the Earth 86 times as much as carbon dioxide over 20 years in the atmosphere. A recent Russian study found that the thawing of underwater permafrost has doubled in the past 3 decades, reaching 18 centimeters a year. One of the consequences has been massive releases of methane from the seafloor, including from hydrates, ice-like formations of solid methane that can explode into gas if they are destabilized. Methane could also raise the acidity of the water and kill off sea creatures as it breaks down. Escaping methane has also been blamed for thousands of underground bubbles and hundreds of mysterious sinkholes. The expedition will next proceed to the Latchev Sea to study megaseeps there. That's the end of that article. So I will leave links below to these articles. So that was the first one. And here's the one that came out a few days ago. This is from the Siberian Times. First pictures and video of the largest methane fountain so far discovered in the Arctic Ocean. This is from October 28th. And here's the picture. It's a big green blob. It's coming up. It's a seep, and it's coming up, and it's coloring the water, that blue-green, that aqua, and that's the methane. And this is off the coast of the Bennett Island. So now let's look at this. Unexpectedly high level of subsea permafrost degradation was recorded by a Russian-led scientific expedition that spent more than a month in the seas of the eastern Arctic. A record-high methane gas emission in the shape of an underwater fountain was registered at the beginning of October east of Bennett Island in the East Siberian Sea. It was a needle in a haystack chase to find an exact place of a methane seep in dark sea waters, but we found it. Just right off the Academician Kiddish, that's the name of the boat. Scientists noticed a spot of emerald-colored water with gas rushing to surface in thousands of bubble threads. The area of the fountain covered about 5 meters, with water so violently boiling with methane bubbles that scientists skipped using plastic cones for sampling and instead collected the bubbles in buckets. This was the most powerful seep I've ever observed. No one has ever recorded anything similar, said head of the expedition Igor Semiletov. There's another picture of it. Here's another one. Here's the boat. They're standing on the boat looking over. Here it is. That's like science fiction, like a sci-fi movie, like The Blob. Look at that. In some areas, the roof of subsea permafrost thawed to the stability horizons of gas hydrates. Moreover, it has been proved that over the past 30 years, speed of vertical degradation of subsea permafrost doubled compared to previous centuries and reached 18 centimeters per year, which is significantly higher than in earlier estimates. This result makes us reconsider the belief that subsea permafrost is stable and can only thaw by a few meters by the end of the 21st century. Now here's the video. I don't have the sound turned on, but we can watch a little of it. It looks like it's, here's another wave coming. It's the plume just like moves through the water. So, "65 scientists from 12 research organizations across 7 countries were on board the research vessel. Researchers studied seas of the eastern Arctic, East Siberian Sea, Laptev Sea, and Kara Sea. They found high levels of degradation of subsea permafrost. Speed of vertical degradation of subsea permafrost has doubled compared to previous centuries and turned out to be higher than earlier estimates. And microplastic has been discovered in seas off the eastern Arctic, thousands of miles away from residential settlements." So they found plastic in the ocean. And at the end, the rector, Elena Kudryashova, rector of Northern Federal University, Arkhangelsk, says, "Another important subject of our research was study of various types of microplastic in the seas of the eastern Arctic. It is important to compare and analyze results of all expeditions because microplastic represents a serious threat to organisms and sea ecosystems as a whole." Well, how about methane seeps? I think that poses a serious threat to ecosystems. Probably more than microplastics. So now let's dig into this a little bit and look at just do a little bit deeper on Bennett Island. Here's the Wikipedia page about Bennett Island. It's the largest of the islands of the DeLong Islands in the northern part of the East Siberian Sea. The area of this island is approximately 150 square kilometers or 58 square miles, and it has a tombolo, which is a little knob at the end, a mound at the end of it, on its eastern end. The highest point of the island is 426 meters or 1,398 feet high, Mount DeLong, the highest point of the archipelago. Bennett Island is part of the Sakha Republic Administrative Division of Russia. There's a picture. It's in this region here. There's more pictures down here. So it's not a very big island. It was discovered by American explorer George W. DeLong in 1881 and named after James Gordon Bennett Jr., who had financed the expedition. DeLong set out in 1879 aboard the USS Jeannette, hoping to reach Wrangel Island and to discover open seas in the Arctic Ocean near the North Pole. However, the ship entered an ice pack near Herald Island in September 1879 and became trapped. The vessel was crushed by the ice and sank in June of 1881. At that point, the party was forced to trek over the ice on foot, discovering Bennett Island during July 1881 and claiming it for the United States. They remained on the island for several days before setting out again for the New Siberian Islands and the mainland of Siberia. So, now it's Russian territory. Some individuals assert American ownership of Bennett Island and others of the DeLong Group based on the 1881 landing. However, the United States government has never claimed Bennett Island and recognizes it as Russian territory. Here's the geology. Consists of early Paleozoic, late Cretaceous, Pliocene, and Quaternary sedimentary and igneous rocks. So it's made from lava. The oldest rocks outcropping on Bennett Island are moderately tilted marine Cambrian to Ordovician sedimentary rocks. Okay, on and on. It says basaltic lava and tuff with lenses of tufaceous argillite. The late Cretaceous strata is overlain by basaltic lavas ranging in age from Pliocene to Quaternary. The Quaternary volcanic rocks form volcanic cones. So it's a volcanic island. So with it being a volcanic island, and there are also there's volcanoes underneath on the Gackel Ridge that go along under there. So it could very easily be releasing methane. Methane is one of the gases that is released from cracks in the earth due to volcanoes and earthquakes and things like that. It's got some glaciers. It's got the largest permanent ice cover. Bennett Island has the largest permanent ice cover within the DeLong Islands. It's got permanent ice cap consisted of 4 separate glaciers, and so on. Now, here's this picture of it. This is the ice around it, but this is the island. Here's the extension on that east side. I'm thinking that's kind of where they found the methane. It got vegetation. Okay, now on this section it says atmospheric plumes. They call it atmospheric plumes. Here it is. See the plume coming up from the island like that? I'm thinking that's the methane plumes. And this has been going on for a long time. This is not the first. This is the first time they've been up there to really measure it. Okay, Bennett Island plumes are a phenomenon in the Arctic that had been a mystery to atmospheric scientists for decades until it was finally explained by a collaborative post-Cold War United States and Russian expedition in the 1990s. For years, scientists observed large, sometimes hundreds of miles long plumes emanating from the northeast corner of Russia over the remote Bennett Island, and scientists hypothesized that the plumes were caused by volcanoes, gas plumes, or even Soviet Cold War testing before satellite observations revealed them to be meteorological in origin. Here we go. The most popular theory among scientists was that the plumes were formed when clathrates, methane, trapped and frozen into a crystalline structure similar to ice by a combination of low temperatures and high pressures, melted and released methane gas. These gas deposits can melt, bubble to the surface, and erupt like a geyser into the atmosphere. So there you go. So this is a place where it's been happening for a very long time. Due to remaining Cold War tensions and the Soviet military's desire to protect the secrecy of submarine facilities, Western scientists were only able to observe the plumes remotely via satellite. The melting permafrost clathrate hypothesis was unable to be tested until spring of 1992, when U.S. and Russian scientists in Siberia were able to conduct an airborne expedition, conduct a sampling of the plume, and surprisingly found no methane. Scientists had initially dismissed the meteorological explanation of the clouds because the plumes only seemed to be unique to Bennett Island and not the other similar islands, and because it was thought that the 1,000-foot-high island was too low to generate orographic clouds. Orographic clouds normally form when air is forced to rise as it passes over a mountain and cools. Bennett Island plumes form due to layering of the Arctic air at different very cold temperatures. The region is relatively remote, with only warm polynyas, open waters surrounded by sea ice, to potentially provide instability. When air hits the elevated Bennett Island, which behaves like an airplane airfoil, it rises up, sometimes to over 3 kilometers, nucleates, condenses, and forms a cloud. The catalyst for the generation of the plumes was difficult to pinpoint because the apparent source region of the plume can appear to shift with time depending on the weakening or intensification of the strength of the wind flowing over the mountain. Consequently, the plumes were determined to be excellent indicators of the location of Arctic fronts and jet stream activity. Presently, the mystery of Bennett Island plumes has not completely been solved. Scientists are still seeking an explanation of why the plumes form at an unusually high altitude of over 3 kilometers or 1.9 miles above the mountaintops. Scientists are also studying the dynamics of the island and why its unique shape is able to generate these plumes. Well, maybe they're coming up out of the water, and it just looks like they're coming up from the mountain. Here we look at NASA Worldview. I have the blue marble layer turned on, so to block out all the clouds. Here's the Arctic. Here's Siberia. Here's the islands. And if we zoom in, here's the Bennett Island. And if we flip it around, that's the eastern side of it. Or maybe that's okay, that little knob, that's the eastern side. So that's the island. It's tiny. So this is the East Siberia Sea here. Here's the Chukchi Sea. This is the East Siberia ice shelf. And so this is where all that permafrost is melting. It's not very deep there. The water's not very deep. So it can heat up faster. We can also look at it on Google Earth. So here's Russia, Siberia. Here's these other islands, and here's Bennett Island right here. There it is. And there's the ice cap. The permanent ice cap that they mention in the article. So it's a pretty important little island. I'm thinking it was probably formed from volcanic activity as the earth was shifting and changing and moving, and so it's got volcanic qualities, and so it can definitely release methane. So here it is, right over here. So that's what I had for you today. We will keep watching this area. So on the earthquake map, it's easy to see. Now here's where the plate line is. This is the North American plate. This is the Eurasia plate. Here's the plate line. It's not too far from that. And where's the island? Here it is. It's right there. We don't see a lot of earthquakes up here, but we do see them. We do see them in the Arctic region, but not right. I haven't seen them right there specifically. So here's the Laptev Sea. Here's the Yamal Peninsula. Here's the Kara Sea. Here's Novaya Zemlya. So that's the orientation on it. So I just thought I would bring y'all up to date on my thoughts on this, and I do believe that it is from maybe underwater volcanic activity, the earth cracking open, also if magma's coming up higher, it's also going to be melting the permafrost in the sediments, and so that would release the methane. So I'll sign off for now, and I'm going to do a methane and sea ice update tomorrow and publish that. If you enjoy my work and would like to contribute or support, my work, support me, I have a PayPal link in the description box below, or you can subscribe to my Subscribestar page where you get all the latest updates on everything. So, again, my name is Margo, and I do believe we are in the end times, and this is the reason I'm doing this researching and bringing it to you, to show you how close we are, and we're seeing all the signs of the ends of the age, in the end of times, as described in the Bible. And I recommend everyone get your spiritual house in order before it's too late. And I did a video this morning, a talk on Blog Talk Radio, and then I made it into a video over on YouTube about decluttering and my spiritual journey through decluttering for the last month or so. And I think it is definitely a step in getting ready to leave the planet and getting your spiritual house in order, and I talk all about that. So until next time, I'm praying for everybody. So God bless you, and go in peace, and I'll talk to you soon. Goodbye.